Meta just told NVIDIA it's coming for its lunch. The company is building its own AI chips and it's not dabbling anymore. It has a roadmap for 4 new generations of custom silicon shipping by the end of 2027. Here's what that means for the AI hardware market, for costs, and for anyone building on top of these platforms. Let me break down what actually happened. Back in March 2025, Reuters reported that Meta had begun testing its first in-house chip designed specifically for AI training. That chip was manufactured with TSMC and it marked a real milestone. Meta had tried this before and failed. In 2022, it scrapped an earlier chip design after it didn't meet internal expectations, and the company went back to buying billions of dollars worth of NVIDIA GPUs. But this time, things went differently. Meta completed what's called a tape-out, which is the moment you finalize a chip design and send it to the factory for initial production. That step alone costs tens of millions of dollars and takes 3 to 6 months. If it fails, you start over. It didn't fail. Fast forward to March 2026, and Meta unveiled a full roadmap. 4 new chips in its MTIA family, the 300, 400, 450, and 500. The MTIA 300 is already in production, handling ranking and recommendation training. The MTIA 400 has finished lab testing and is rolling out to data centers. Meta says it's the first of its chips with raw performance competitive with leading commercial products. That's a direct shot at NVIDIA and AMD. The 450 and 500 are scheduled for mass deployment in 2027, with the 500 packing up to 512 gigabytes of high-bandwidth memory and 30 petaflops of compute. Think of it this way. Instead of renting someone else's kitchen to cook every meal, Meta is building its own restaurant from the ground up, custom ovens and all, and they're releasing a new oven model every 6 months. Now here's why this matters if you run a business or work in tech. These chips are built in partnership with Broadcom, not just TSMC. They use RISC-V cores. They're designed around open standards like PyTorch, vLLM, and Triton, meaning developers can port existing models without special adaptations. That's a deliberate choice to make adoption frictionless. What does this change practically? 3 scenarios. First, if you're a company buying cloud compute for AI workloads, this signals that infrastructure costs are heading down. Meta projected up to $65 billion in capital expenditure for 2025, much of it on NVIDIA GPUs. Every dollar Meta saves on chips is a dollar that can go toward cheaper AI services on its platforms. That pressure flows downstream. Second, if you work in AI infrastructure or procurement, the supplier landscape is fragmenting. Meta signed multi-year, multi-generational deals with both NVIDIA and AMD, even while building its own chips. That's a hedge. The smart move for any organization is to diversify hardware dependencies the same way. Third, if you build on Meta's platforms or use its AI tools, expect faster, cheaper inference. The MTIA 450 doubles the memory bandwidth of the 400. Meta says its performance is, quote, much higher than that of existing leading commercial products. When inference gets cheaper, AI features get embedded everywhere, from Instagram recommendations to Meta AI chatbot responses. But let's talk about what can go wrong. Meta's track record here is mixed. It scrapped a chip in 2022. Chris Cox, Meta's chief product officer, described the whole process as a walk, crawl, run situation. That's honest, and it's a warning. Custom silicon is extraordinarily hard. The tape-out process alone is a high-stakes gamble. There's also the question of whether Meta's chips will ever handle frontier model training at the scale of Llama. Right now, the initial focus is recommendation systems. Generative AI training comes later, and Meta is still spending billions on NVIDIA and AMD chips. In February 2026, it signed a deal with AMD for up to 6 gigawatts of Instinct GPU compute. So this isn't a replacement story, it's a diversification story. NVIDIA's stock is still up roughly 60% year over year. Another risk: concentration. If Meta builds hardware tightly optimized for its own workloads, that's great for Meta, but it could make the broader ecosystem more fragmented, with each hyperscaler running proprietary silicon that doesn't benefit the wider market. So what should you do with this information in the next 30 days? 1. Audit your own AI hardware dependencies. If you rely heavily on a single GPU vendor, start evaluating alternatives now while you have leverage. 2. Watch inference pricing on Meta's platforms. As MTIA chips roll out, expect cost per query to drop. If you're building applications on Meta AI or using its recommendation APIs, budget accordingly. 3. If you're in semiconductor investing or procurement, track Broadcom closely. Meta's partnership there is significant, and Broadcom has confirmed multiple gigawatts of Metachip installations coming in 2027 and beyond. 4. Pressure test your AI models on multiple hardware backends. Meta designed MTIA to be compatible with PyTorch and standard tooling. That's the direction the industry is moving. Models that only run well on one vendor's hardware are a liability. 5. Revisit your AI infrastructure roadmap quarterly, not annually. When a company the size of Meta ships a new chip generation every 6 months, the cost and performance landscape shifts fast. The bottom line, Meta is no longer just a customer in the AI chip market, it's becoming a competitor, and that changes the economics of AI infrastructure for everyone. If you want to stay ahead of these shifts, subscribe to AI Blueprint. We break down the news that actually moves the needle.